Well, good evening, ladies and gentlemen. I think we're going to begin now. So, for those aficionados of Grantham's special lectures, you might remember Dr. Fatih Birol from the International Energy Agency talking to us earlier in the year, and he talked about the special position of China, that most of the decisions that really matter will be in the energy area are going to be made in Beijing. And it's a great pleasure for us today to welcome people from the Energy Research Institute in China. And Professor Han Wenke, who is Director General, should be arriving any time, we hope. And I'll introduce him later on, perhaps, to make a few comments. The first talk from the Energy Research Institute then is going to be presented by Professor Han's colleague, Dr. Yang Yufeng, and he's going to tell us about the outcome of his studies of China's energy pathway to 2050. But I was going to sketch to you the course of way the events may go this evening, and I'm not sure I know myself at this point, having reached here, but anyway, Dr. Yang will actually give the first talk, and then, assuming Professor Han is here, then we'll let him have a few words. Then there'll be some question and answer on that. And then after that, Dr. Ajay Gambhir, for the research fellow from the Grantham Research Institute, will present his work on China's long-term energy outlook, and that's been done under the Avoid project, which is funded by DEC. So we'll come to that later on, and I would now like to ask Dr. Yang to present his talk.
Good evening, everyone. It's my great pleasure to be here to give a brief introduction about our work. This work is a collaboration between UK and China. Its name is China 2050 Pathway. I'm very sorry I'm a bit late here because of the traffic jam. It's my reason, sorry. So. However, this work is very important by now, but it's just initial results now. So, sorry. Okay, it's supported by it's United Kingdom, the Foreign Commonwealth Office. From technical support is from the DEC. Here, I would like to give my thanks especially to the Mr. Leo Gerdes and Mr. Kiesel's team, give our many support in the technology for this work. Here is our team because this project, in fact, about not near 1 year, in fact, we works from our side. We very seriously to do these works in our team. Today is my content I would like to present to everyone. So firstly, I would like to give you a background about China and UK. What's the difference? Yeah, because at the beginning of these works, we noticed for China it's more complicated because large areas, large populations, and the difference from the north to south, from west to east, and the industry sectors, is all of these things is very complicated than the United Kingdom. So this research works for us. It's very challenging. Here is just 5 aspects, 5 areas difference we listed. This is our initial results. It's very sorry, it's a Chinese version, but it's very small. Including the supply side, demand side, and the 2050 scenarios. This is a website where but now it is still not in the web. Sorry, but very soon I think we will be web. To do this project, we have a very important things. We call for evidences from our different organizations, including our government, especially, for example, our NERC, because for some high officials even, some of them, in fact, meanwhile, they are the anti-experts. So this work cannot leave this kind of persons in the different organizations. This all is our chief, some organizations involved in these works. Following, I would like to introduce is what presently in China is the situations in. There are now 4 figures I would like to provide you. One is our rapid growth demand in the economic side and the demand side. You must notice for China, for past 30 years, we have high correlations between economy and energy demand. And another is our energy mix is very, very different with other countries. We heavily depend on our coal. Even now, it still have some changes. Another is totally, comprehensively, I think, in China, we still low efficiency in different sectors, different, everywhere, I think. Here is a figure compared with other main countries. This is the present situation. This is our 2050 baseline for the fields for the 2050. You may find out this baseline of fields is very, very, it's a worst, I think, worst scenarios. This means if this kind of scenarios continues in the fields, our China will have to face the 6 serious problems. This is still very important, I think, in fields. For our government, or the society, or the public, we all very concerned about this. Even some villagers, the residents, they all began to care about, concern about all of the problems. Now we have to consider what we can do in the fields. Any country, I think, we cannot live with 2 tools, in fact. One is from government, another is the market. So the market-oriented and the command and controls regulations in the field is how to design this in the whole society for our government is very, very important. Here we cannot leave the 3 areas, one is government, enterprises, and public. By now, in fact, especially recent 5 years, I think, for our 11th 5 years, we have great achievement. Everyone noticed, perhaps, especially our very rapid economic growth, I think. For the energy itself is true, yes. For example, in industry, our energy intensity decreased very quickly from 2010. For the energy consumption per unit product is decreased very greatly too. And including for the renewable energy, for example, we have a very, very quickly installed capacity rate recent years. In the transportation, it's like other countries, even like developed countries. In fact, in China now, different cities, different life levels cities, for some especially like Beijing, Guangdong, and Shanghai, like this kind of very large cities. We have, in fact, all of the different technologies, transportation tools. For example, the BRT developed very quickly. For example, in Chongqing, Even in Beijing, we designed some special lines for the public buses. All of this is very important for us in the field. Another is our energy conservation, because our government from at least I think 10 years ago, we already very paid much attention for any kind of energy conservation in our sectors, especially in our industries. So these areas we really get already great achievements too. But now it's still enough, I think. We still have great potentials. So in the fields, some related policies still have all of this kind of, here I listed some of them, some areas, you know. But from 2 years ago in China, in fact, and here I must refer a special, our policies is, we call it in English is total energy consumption ceilings. Because this is, however, is a new policy for us. It's very, very important, and this is a great change for China government. Because traditionally, we always pay attention to the supply side. We always means we have energy supply, we can develop supply development. But this is, however, from the first time is from the demand side. We need to limit our energy consumption amount. This is absolute amount limit. We will design the ceilings. This means, in fact, for the carbon dioxide, we will have very easily to convert it into the limit too. So this is a new policy for us, however. When we consider now, we return our scenarios, our work, our 2050 pathways. So here, how to consider this work's designs. 1 year ago began this design, because this calculator is a design. So we cannot leave two sides still. It's the energy supply side and the demand side. For the energy supply side and demand side, we have the priorities, in fact, for the different technologies and the different fossil fuels, renewable energies, new energy technologies, alternatives. So these two sides is very important how to design in the fields. For the energy supply side, we have 4 areas here, including, for example, the renewable energy deployment, still very important, although we already achieved it greatly. The other is the alternative energy strategy, including clean coal technology. The clean coal technology in China is perhaps now more different with other countries. Everyone knows for China, we heavily depend on the coal. And now we still have nearly 70% of the for the whole energy mix. Still have the very great, very big percentage here. So this is very crucial, I believe. Another is nuclear power development. Especially after last year's Japan's accident, our government's reassessment to have all of the different plan and different different product, you know. But now this is still for China is very important. So here's some details. For example, just to give some examples here. For example, renewable energy development for the wind power roadmap. Here, we specifically have, in fact, collaboration with IEA, specifically designed this our wind power roadmap. So for the wind power is more clear in the field. For alternative energy strategy, here I just would like to give you two areas. One is the transportation, another is power generation. Because these two areas in the fields, however, is very important. For the transportation areas, in fact, it's highly related with our energy securities, especially for the oil consumption. These areas is very, very crucial, and it means how about this kind of technologies can be used in the field is very, very crucial for our China's energy security, I think. Secondly is the power generation, another very crucial areas for China, because it's dependent on, just I already referred this, for example, the coal power generation. Because we can, sooner or later, I believe, we cannot depend, permanently depend on the coal. Yeah. So, but here I have to put forward is for the CCS, you know. The CCS area now is a very hot topic right now in the world. But now I'm not a technology background expert, but I have some Antieconomic analysis for the CCS. So at least I myself know CCS now is still full of uncertainties, especially because this kind of technology is now just input the money, but cannot return something, especially for the coal power generation now. So very possibly in the field, so if this kind of technology can be very the cost benefits in the business, I believe it's a lower. But however, in our scenario, we still use it. Yes. For the nuclear power generation in China, we still because have this kind of some objectives for some this industry objectives. So we design it in the fields, but still face great challenges too. From demand side, we have four areas too. The first is the economic structure. Everyone knows is China now. We have to do many works in the economic transitions. You know, I mean. Here is highly related with industry, transportation, and buildings. Yeah. These other three, in fact, areas is highly related with this objective. So, in the at the demand side, for the economic structure, for example, we have to do some changes in the field. Here we have some details. I will not introduce more details here. For industries too, and the transportation and the buildings, we must use the more clean, more low carbon technologies. Yeah. However, this is in our 2050 pathways considerations. I just gave very quickly gave you from the supply side and the demand side. But this works in the fields. We still have many challenges. Here I have the 7 aspects, 7 areas, including the long existing economic structure. This is very difficult to change the present structure. For example, for local government, for some industry, for some business, they already have some deployment. They already have great cost, you know. So the changes is very difficult. But our government have this kind of solutions, I think. Other kind of errors is two in the field. This figure is our calculator. This calculator's result in the 2050 pathway, and after all, this is very optimistic scenarios and very ambitious. But I already told everyone is we have from the supply side and the demand side we have the priorities deployment for our scenario designs, and this is a result. Yeah. The next step for this work, we need to improve our models because now we just finished the very basics works. For example, the co-fault evidences, we just in fact met some experts, not the officials, for example. Although they include some officials, they meanwhile they are the experts. But we still need to extend the large scales. This is very important for us. Another one is in these tools, we will pay much attention. Very important is two things. One is the cost. Well, this means we already designed the scenarios, but what the cost? So every items we have a cost. So here, this cost is very important because, for example, my boss, my leaders will always ask me, you design a very beautiful scenario in the field, but the cost, is it possible in the field? So the cost is very important in the field's works for us. At least we need to clearly list some details, what kind of cost. Some costs can be calculated, but some of them cannot be calculated. But we need clearly and point out, I believe, in order to more understand our works. Another is the air pollution. And this is different for other countries, perhaps. China, after all, is a highly developing country still. We face environment problem always, in fact, two. One is the local environment, local pollutions, Another is the global one, global greenhouse gases. So meanwhile, we must do these two works, in fact. All of these two works is highly related. For example, we can design the low carbon some scenarios. Meanwhile, in fact, we can encourage our local pollutions, but still different because for China, we still in the process of quick urbanizations, for example. For example, the transportation pollutions is very serious for some large cities. So it's very special, The final is my 2050 is just like the same term in the United Kingdom, the same work. This means we need to expand our more audiences. This is very important because mainly for the education, I think, for the training. This training is very important for China. Is we must not only the schools, children, or some students in the university, but also for our different levels officials is more important. For the business is more important because in China we have many private business enterprises. We must let them to understand our works. This is more important. So next step, we have see this kind of areas we need to do. Thank you very much.
Thank you, Dr. Yang. And you you be prepared to answer some questions on the basis of your talk? Okay, good. Right. Who would like to ask Dr. Yang a question about the roadmap to 2050? Yes, James.
Thank you. My name's James Smith. I'm the chairman of the Carbon Trust in the UK. Dr. Yang, thank you very much for your excellent talk, and thank you very much for coming here to give it to us. It was, I found it extremely useful. You talked about carbon capture and storage, and I know you said it wasn't an area of your particular expertise, but I wonder if you would mind if I ask you a bit more about it. I'm just conscious when we run models on climate change, whether it's for coal or for gas or for biomass that would give us negative CO2, whether it's in North America or Europe or India and China, it looks as if we can't fix climate change if we haven't got carbon capture and storage. And I was just wondering if you had any perspective that China might be able to lead the world on developing and implementing the technologies.
Okay. 首先要感谢杨博士来到英国，非常我的名字叫 James Smith， 我是碳信托基金的在那边工作。今天呢，非常感谢您到此来对大家做这次演讲。刚才你也谈到了对碳的普及和封存技术，您在这方面并不是专家，但是我希望您不介意，我还是就这个领域提一些问题。因为对于气候变化这个问题，我们很多模型是需要改进的，尤其是碳捕集的这个问题，不管是北美啊、中国啊、欧洲啊，都遇到二氧化碳排放的问题。那么我想问一下，中国是否也想从自己的角度，尽可能成为世界的领头人，在碳的捕集和封存方面做出一些贡献？
Sorry, because we have my colleagues, so have for some translation. Don't think, for the CCS, I just already referred about this. We all understand that. At least my understanding is, for CCS technology in the field, the largest area is the coal power generation. This is no doubt. I believe everyone agree with me. So, because this is, for this reason, so in the field, China is nearly very special, very biggest market in the field. So this technology is very crucial for the global, not only for China. Although China is the cheap country, I think. So. But we in fact, from our government, I remember 3 years ago, I write an internal report for our government for this CCS technologies. Our government, including our very high officials, I believe, they already began to understand what is the CCS. So the CCS in China, very important. And but we have, in fact, some pilot project, in Chinese. For example, our Huanan group, just in our suburb of Beijing, we have a project this kind of. But it's very limited, I think. It's very costly, I think. So at least now we cannot. Have some results very positive. But we pay much attention to this. And even in my works, I already designed it into it. Okay.
Right, would someone else like to ask a question? Yes, at the back there.
Shall I just shout?
No, I have to wait for that. And you could do it in Chinese or English, whichever you prefer.
I'm not sure which is worst for me. I'm Alan Simpson, I'm a recovering politician, and I was responsible for the feed-in tariff amendments in the 2008 Energy Act. Recently I was involved in bringing some of the German officials across to the UK to talk about the very different energy vision that they're trying to pursue. And at the core of that was this presumption that they will reduce energy demand by 50% by 2020. And when, with the different parliamentary groups, we asked them to explain how they would deliver that, the intriguing thing was that they seemed to be saying that it was going to be a combination of two things. One, really cutting-edge technologies that in themselves reduce energy consumption in everyday living. The iPad, with the example they used, 10 hours battery, but with all dependent on a fraction of the energy requirements. So that was one. But the other was to break the link between the power generators, the energy companies, and citizens in order to create new markets where they could sell non-consumption rather than consumption. And I wonder had China done any thinking in moving the whole ground rules about energy markets for the future?
Sorry, I didn't get your name, sir.
Alan Simpson.
Alan Simpson.我的名字叫 Alan Simpson， 我是在议会工作。今天想问的问题就是也是关于能源。我们最近呢，英国邀请了一些德国的官员来谈谈他们有什么样的不同的节能方法。其中呢，德国就谈到他们2020年的目标对能源就是将能源的需求减半。那么我们问他怎么做到的时候，他们说有2个主要的方法，主要是采用的技术组合。第一个是采用非常先进的技术，非常尖端的技术。这方面呢，就是说从技术本身来讲，减少能源消耗。比如说我用的 iPad，有10个小时的电池寿命。从这个方面说，就是这项技术能够大大的降低能源的消耗。第二个呢，就是从我们发电的角度来讲，要把发电的过程和民用电的这个过程断开来。这样的话呢，我们在市场上就不会直接去消耗那些能源，而是用电。我想问问中国对此而言有什么想法
？Very, very good questions. Here I just provide you some informations. For our China, because China is a large country, nearly any kind of technologies in China market, I believe, we can use in the field. So some very high technologies, advanced technologies can be used, no problem. We very seriously consider this. This is no doubt, yeah. The second is, for us, is we, from the supply side, we have great changes. In my scenarios, in fact, is, for example, we will greatly large scales to develop the renewable energies, or including the nuclear energies, etc. But except all of this point, I here would like to provide an example. Is many years, for example, Japan. In Japan, for example, we always compare efficiency, energy efficiency with Japan. We found out in Japan it's very high efficiencies, but China's every sectors, every industries is low efficiencies, even including our resident, the dental sectors. But recently we found out, except the technology itself, in fact, absolute amount itself is very important. We went into a very office building in Japan when we visited. But the lighting is very many lighting. The lighting is green, no problem. It's a convenient lighting. But the per capita energy consumption in Japan is very high, several times than China still. When one of our friend in Japan is switch off half of the light that building, we calculate is per capita with our China's consumption is still more than ours per capita. This means is the amount I hear is very, very important. Everyone need to, in the field, to from different angles, different aspects, to do some low carbon and innovative behavior. I think so important.
Yes.
My name is Jason. I'm nobody compared to.
Oh, sorry. Can you just wait?
I'm just gonna ask something very simple. Is this research going to be ready to be published here or anywhere in China, or because the best way to educate the Chinese population is to let everyone read this stuff, and instead of host this presentation in UK, you should host it in China, I think. I'm just asking.
你好，我的名字叫 Jason。我想问的是，这份报告在国内有没有发表？因为对于中国来说，最好的教育公众的方法就是发表您的报告，让人人都读，而不是来英国做演讲。
Yes, definitely. Very good question. Yeah. Because by now it's just a research period still. It's an initial result. In fact, this project I believe is very different with other research method, other anti-modeling works, for example. From the deck, I believe it's open to the public, because there are three words in fact. One of them is the to the public. So this work is very quickly, I believe, will be open to the public. You can check the details. It's whether or not it's right or mistakes. You can simulate it by these tools. So no problem in the fields, I believe. This is our objective. The final objective is the education for the whole society.
Right, we'll have one more question now then from the lady there.
Thanks, Dr. Yang, for your very good presentation. You give us very clean the picture and the pattern about the technology approach in China in the future, the 3 decades. But I was wonder the very clean technological approach to increase energy efficiency and decrease carbon emission. But from official Chinese government official level, what political economic institutions Chinese government use to promote the innovative technological approach to achieve the target? And secondly, from social level, what social public support scheme and legal level market mechanism scheme create government and Chinese society? Thank you very much.
非常感谢杨博士的演讲，给我们提供了，让我们很清楚地看到了中国的能源技术的发展，在未来的重要性。我想请问呢，我从您的演讲中了解了中国的技术现在正努力提高能源效率，降低碳排放。我的问题呢是，在中国政府方面有哪些经济体制上的机制来推动创新技术的发展？第二个问题呢，就是从社会的角度来讲，社会上有没有一些支持机制来帮助这些技术的发展，从而有利于这些技术在社会上得到更好的推广
Yes, that's very good questions. You know, in fact, in my presentation, I already referred this questions answers, and from the government. we very much pay attention to the technologies. Because our government already noticed many times in the history, in fact, the innovations in the development of the high technology, in fact, provide the world is great changes. So the low carbon technologies, anti-conservation technologies, and green technologies, we pay much attention, I believe. So from the government, no problem, I believe. I already, in fact, have many tools from the different levels. For example, some financial measure, some market-oriented, some taxation measure, and etc. I believe we government is very concerned about this. From the business and the public, I think, because now China's for the normal life, in everywhere is with the development of the economy, everyone's life is higher and higher. They have more and more requirements, including to the environment qualities. So even residents in villages, I believe, now in China, it's not like several years ago. They already have great this kind of concerns. So for the from public, from the enterprises, we have different this kind of regulations, some measure, mainly from the demand side, I believe. So I agree with your views.
Thank you, Dr. Yang. So we heard from Dr. Yang Yufeng from the Energy Research Institute in China, and now I'd like to present to you the director of that institute, Professor Han Wenke. So he's Director General of the Energy Research Institute at the National Development and Reform Commission of China, and a very influential man in China in these matters. And he's also Editor General and Director of the magazine China Energy, committee member of the National Energy Expert Committee, and a member of the China Energy Research Society, the Investment Association of China, the China Economic and Social Council, and the China Energy Conservation Association. And I'm very glad he found time to come here today. And I welcome you to give a few words, Professor Han.
先生们，大家晚上好。很高兴能来到这个地宫理工大学，在这个地方做一点这个，我想给大家介绍一点中国的情况。
Can you hear me? Thank you. Good evening, ladies and gentlemen. It's a great pleasure to come to Imperial College London. I'd like to talk about something about China now.
首先做一点自我介绍。我们这个能源研究所里是中国专门研究能源政策的一个机构。那么我们是在这个80年代，就80年的时候建立的。大家知道70年代世界经过了这个能源危机，中国的在80年代初期的时候决定要走改革开放的道路，所以这个中国意识到今后这个能源问题会很重要，就建立了这么一个专门研究能源政策的机构。我们现在有100多人，专门从事能源政策方面的研究。
I'd like to briefly introduce to you the Energy Research Institute. This is an organization specifically study and do research on the energy policy in China. Everybody knows that in 1970s, the world had energy crisis. So in 1980s, China decided to open up and carry out its reform. So since then, the energy question has become one of the most important questions. That is why our country established Energy Research Institute, and we so far have roughly 100 people to carry out research work in this area.
我们的研究工作里主要有几个领域，一个就是我们在研究这个中国关于能源发展的战略，中长期的战略，比如说中国到2020年、到2030年、到2050年，能源应该是一个什么样的发展战略？这是一个这个比较长期研究的一项任务。
There are several areas that I would like to focus on. Firstly, China's energy development strategy, especially the mid to long-term strategies. For example, the strategies for 2020, 2030, and 2050. This will require our long-term efforts.
那么我们现在这种对中国能源发展战略的研究呢，就要和国际上结合起来。大家知道，中国的这个能源增长速度一直比较快，世界上有很多担心，大家担心说中国可能需要更多的能源，这个世界的资源满足不了。那么世界上像英国这样的发达国家，它的能源的这个增速是非常低的，有些国家已经是负增长了。所以我们在研究长期的中国的能源发展战略的时候，就要看到这些。我们要和这个世界各国的主要的这个放眼未来的能源研究的这些战略家、政府人员和研究工作者要进行合作，研究出来一个对中国非常有前瞻性的一个能源战略。
Talking about China's energy strategies, we need to look at the world as the background picture. Everybody knows that China's energy growth is really fast. It's actually too fast that the world starts to worry about how much energy we're going to consume, because the world resources is limited. And developed countries such as UK, the energy growth is really low. Sometimes it's negative. And so when we decide to develop more, we need to work more with governments around the world and talk with them, consult experts, so that we take the world into consideration on our way forward.
那么第二个方面就是说，我们要研究中国怎么样去利用能源才更加有效。所以在我们中国就叫这个节能，节能减排，就提高能源效率和减少污染的排放。这是我们一项这个重要的研究工作。
So in China, we're focusing on how to increase the energy efficiency and how to improve our energy conservation work. So that means we need to save more energy and reduce emission, therefore reduce pollution.
那么我从2000年就到英国来访问，我到伦敦来过，这次应该是第6次。前几次的主要就是这个和英国的同行交流这个能源效率。
This is actually the 6th visit to the UK for me since 2000, and I have been talking to my UK counterparts regarding energy efficiency.
那么我们另外一个研究领域就是要研究这个气候变化，研究气候变化的政策。我们要研究中国采取什么样的这个国内的能源和环境政策，来应对全球气候变化。这个制定国家的这个应对气候变化的国家的行动方案。同时，我们也研究中国用什么样的态度，采取什么样的步骤。 去参与全球应对气候变化的这种合作，去进行国际谈判，承担什么样的义务
？Another question is the climate change policies. what kind of policies and what kind of attitudes China should adopt to face the world climate change, especially our methods and actions, how to behave when we participate in international cooperation, how we negotiate with the world regarding climate change, and what responsibilities we need to take.
那么，另外一项这个研究工作就是我们研究这个可再生能源，特别是非化石能源，怎么样能够发展起来？采用什么样的政策，使它能够更快速的发展起来？这一方面，我们和欧盟有很紧密的合作。比如说，我们从德国、这个丹麦，这些包括英国有很长远的这个历史比较长的合作，同时的，我们也在中国里制定了这个，就是研究制定这个可再生能源的法规等等，来促进可再生能源的发展。
Another aspect is the renewable energy, how to use more non-fossil fuels, how to develop, how to make policies to help the development of renewable energies. In this area, we have a lot of cooperation with European Union, including countries such as Germany, Denmark, and UK. With them, we have been engaging in long-term cooperation. Within China, at the meantime, we have set up rules and regulations to help the development of renewable energies.
那么我们好多研究成果已经被中国政府采纳了。制定成中国的这个阶段性的发展目标，比如说未来5年的发展目标，到2020年的发展目标，有些已经制定成政策了。
The government has adopted some of our research results, and some of them has already been integrated into the policy-making process. For example, what our targets will be in the next 5 years, what the targets will be in 2020. And some of them already become part of our policy.
但是这些远远不够，这个从中国的发展来讲，我们也要看得更远。我们研究到2050年，中国这些问题应该是一个什么样的发展趋势？同时，从全球应对气候变化来看，这个未来今后谈判的重点就是像中国这样的发展中国家，在2020年以后。应该承担什么样的这个义务和责任？那么，所以我们和英国这个有关部门合作，要研究2050的这个发展，这也是我们这一次到这里来交流的一个目的。
However, whatever we have done is far from enough. We need to consider the long-term benefits for China as well as the world. For example, by 2050. What problems could there be, and how to develop more? Regarding the future for climate change, we have been involved in many negotiations. For example, after 2020, what kind of development does China want to pursue, and what responsibilities we should take? That is partly why I come here to visit our UK counterparts to discuss our 2050 pathways.
所以我们研究2050的这个中国的这个能源啊、气候变化这些问题的，我们和英国的同行里找到了一个工具，就是我们刚才杨博士介绍这个2050的这个 pathway 这么一个工具，这样提供一个平台，我们和英国的这个同行里，他们也在研究，我们可以和他们交流，同时也可以了解这个。像英国的国际社会对中国有什么期待？把这些东西揉进去，应该有利于我们开发更多的这种政策研究的工具，促进我们这个研究工作和世界更好的协调起来。我想这是我们这来的目的。我想，给我一点时间呢，我就做这点介绍。谢谢大
家。Regarding the energy issue, as well as the climate change in 2050, we have a lot of cooperation with the UK specifically, This has been mentioned in Dr. Young's report. The pathway is a tool for us to do more research on this issue. And this has enabled us to build a better platform to communicate with our UK counterparts, to do more research and see what changes we can make. And also, it helps us to understand what the UK and the world expect from us. This will benefit our policy making and benefit our cooperation with the world. Thank you for giving me this time to talk to you.
Thank you very much indeed, Professor Han, for those interesting and wise words. So I think we will now move on to the talk by A.J. Gambier from the Grantham Research Institute at Imperial, and the Grantham Institute for Climate Change at Imperial, even though I'm confused with the LSE Grantham Institute. And so AJ has been working on this project, as I say, funded by DEC, the Avoid project, and he's going to tell us about another perspective on the pathway to 2050 for China.
Okay, thank you everyone. I'm going to make some relatively quick comments on the study that we did last year, looking at China's energy technologies to 2050. It will be interesting to try and draw out some comparisons between this study and some of what's already been presented to you earlier today. I'd like to start just by thanking the funders of this study. As Brian mentioned, it was done as part of the Avoid programme, which is about avoiding dangerous climate change. That's funded by the UK government and DEC and DEFRA in particular. But I'd also like to thank the Foreign and Commonwealth Office as well, with whom we liaised heavily, particularly those in Beijing. We had a very fruitful interaction with those people over there. The Avoid core questions, some of you may have already spotted them from the banner over there, are about considering what levels of climate change are potentially dangerous, what emissions pathways would avoid such dangerous levels of climate change, and how feasible those pathways are. And the focus of this study is very much on the second two questions. So we're looking at how could China significantly reduce its CO2 emissions as part of a 2°C pathway. And the particular pathway we're looking at gives a better than 50-50 chance of staying below 2°C. And then what are the challenges and opportunities for China in achieving that pathway? This is a very sort of high-level overview of the results from the study. The faded lines going up to about 13 gigatons of CO2 per year by 2050. Effectively, that's the reference case, or the business as usual, quite similar actually to what Dr. Yang presented in his baseline scenario. The solid wedges at the bottom show what the low carbon scenario would be. So the sum total of industry, transport, buildings and energy conversion or energy losses would add up to below 4 gigatons of CO2 by 2050. So a very drastic decarbonisation possible from our scenarios. And it's worth saying that this is in a context where China's GDP is projected to grow by 500%, or rather sixfold, between now and 2050. So this isn't a low economic growth scenario. It very much continues the strong growth in China's economy. I'll talk in a bit more detail about what achieves the emissions reductions in each of the sectors shown, but it's worth saying that they include any electricity usage. So this is a end-use view of the world. One of the big things underpinning the low-carbon scenarios that we modelled, and sorry, I should say, just going back a couple of slides, that the Grantham Institute did this in partnership with the International Institute for Applied Systems Analysis, IASA in Austria, using their integrated assessment model and energy technology model message. So it was IASA that modelled the supply side and particularly the power sector of China's economy for us. Some very striking results come out of that modelling. Compared to a 2005 electricity generation of about 10 exajoules per year, this study projects electricity generation to grow more than threefold out to 2050. And looking at the carbon intensities in the reference case and the low carbon case, you can see that whereas the reference scenario would maintain about 800 grams of carbon dioxide per kilowatt hour, the low carbon case would see a very, very drastic reduction in CO2 intensity of electricity generation. Many of you will be aware about the Committee on Climate Change advice in the UK, which advocated of the order of 50 grams of CO2 per kilowatt hour by 2030. And this is an indicator that in other regions of the world, a significant decarbonisation along the low carbon pathway would be underpinned by a similar sort of decarbonisation of the power sector. Just drawing out some comparisons with the presentation from earlier this evening, I think Dr. Yang said that there was an aim for something like 1,000 gigawatts of wind generation by 2050. Our study had about 600 gigawatts. We had a very high deployment of solar photovoltaics by 2050, very sensitive to what the cost projections of these technologies are. And the modelling that IASA undertook very much favoured solar PV as a technology with vast cost reduction potential going forward over time. And then finally, to pick up, our nuclear proportion of installed capacity was about 10%, which I think compared to about 15% presented by Dr. Yang. And we, of course, also rely heavily on CCS technologies within our low carbon scenario. So there's a lot of food for thought in that slide alone. Just turning to the industry, transport and buildings sectors, considering that decarbonisation of electricity, in 2050, and this slide shows in 2050 how one would move from the reference case for industry, which is the dark green bar on the left-hand side of the chart, to the low carbon case, which is on the far right of the chart, and what the major reductions would be. There'd be a fair amount from energy efficiency, a huge amount from switching to decarbonised electricity, particularly in the iron and steel and chemical sectors. There'd be some from other fuel switching, such as substituting gas for coal in ammonia production and other chemical processes. And there'd be quite a bit from CCS. We assume that about 75% of emissions from the iron and steel and cement sectors would be captured by CCS technologies. So a very, very large decarbonisation possible technically in the industrial sector by 2050. Turning to transport, overall lower emissions by 2050, something like 2 gigatons of CO2 in the reference scenario compared to something like 6 in industry, but again, a more than halving of emissions possible. It's not all about electric vehicles, although they do feature very prominently. It's a lot about energy efficiency and biofuels usage as well. And electrification happens in not just the road sector, but the rail sector as well. I think China's railways are about 50% diesel and 50% electric at the moment. And this scenario assumed an almost total electrification of rail going forward. Just looking across the other modes, biofuels and energy efficiency are also extremely important. So what starts to come out is that some of the messages that were spoken about earlier in the evening, energy efficiency and so on, are key to many of the different modes and sectors within China. Looking at the building sector, a similar sort of size of projected emissions, about 2 gigatons of CO2 by 2050 in the reference case, but here a very, very large decarbonisation possible. Just moving from the left to the right-hand side of the chart, energy efficiency in building cells provides about 0.2 of a gigaton of savings. Low-carbon electricity for heating, principally through heat pumps, would provide something like 0.3 gigatons. There's a bit from fuel switching away from coal to gas. Energy-efficient appliances could give you a really big saving of over half a gigaton. And then, last but certainly not least, the decarbonisation of electricity through use in appliances and so on would give you the biggest share, something like 0.75 gigatons. So you could, according to our scenario, technically get to about an 80% reduction in emissions compared to the baseline scenario. Again, some non-climate change benefits and imperatives have been alluded to earlier in the evening. There's a lot of detail on this slide, but I think what it's important to say is that if you look at the reference case, by the time you get to 2050, there's a continued reliance on coal and a lot of oil as well. But moving to the low carbon scenario, not only is there a 30 to 40% reduction in overall energy demand, but there's a very, very large demand in oil and coal. And so that would, of course, be particularly attractive from an energy security perspective. I've also highlighted that by 2020, in the low-carbon scenario, the non-fossil share of primary energy would have increased from 10% to 15%, which, of course, is the Copenhagen Accord pledge for China. Again, another theme picking up from earlier is about air pollution. The modelling that we've used within this study assumes a fairly significant drop in air pollutants even in the reference scenario, because it's assumed that China will follow World Health Organization recommendations on limits to local pollution. But that doesn't mean that a low carbon scenario couldn't go much further, and you see there a more than halving of PM2.5, one of the most damaging pollutants to health, by 2050. Our study considered a number of cross-cutting issues and challenges to 2050 as well. We considered the land implications of the increase in biomass and biofuel usage. We concluded that the extensive grasslands within China could be used for biomass, but there are a lot of uncertainties about the cost and technical potential of next generation, second and third generation biofuels. On water, it's of course clear that China's already facing a lot of regional water stress, and a number of the low carbon technologies that we identified in our study, including biomass, hydropower, concentrated solar power and nuclear, would all have the potential to increase water consumption. So the positioning of power plants and so on would be incredibly important. So there'd be a number of spatial planning issues that our study didn't model, but that we highlighted would need to be considered as part of any low carbon scenario. On coal and oil, as I indicated a couple of slides ago, the baseline or the reference scenario would create significant challenges in terms of continued reliance on coal. And although China, of course, has vast coal reserves, as they're used up, they become increasingly uneconomic, and there are a number of environmental issues to address there as well. Oil imports would decrease significantly in the low carbon scenario, but it's worth noting that China, in our scenario, would still be a major oil importer by 2050. Looking at gas, we think that gas usage would actually increase in the low carbon scenario, and I think Dr. Yang presented something similar in his slides. Those of you that are aware of the key messages from the World Energy Outlook from last year will know that there are potentially vast unconventional reserves of gas, and a key question there is whether they can be economically extracted and in an environmentally safe way. And the nuclear question, of course, leads to increased imports of uranium. According to our calculation, China's reserves would service about 1/10 of the projected demand of nuclear in our scenarios to 2050. So that would lead to an increased import reliance. A final challenge, just to point out, is the incredibly technically complex challenge of integrating very geographically diverse sources of power generation, particularly those that are intermittent in nature as well, such as solar and wind, and making sure that the system balances and that those sources of generation can get to centres of demand. I won't attempt to remember where all of the sites of generation are, but there's a lot of wind on the east coast, but there's a lot of solar in the northwest, there's a lot of hydropower in the southwest. Some of these sources are very, very far, thousands of kilometres in many cases from demand centres, and to the extent that it's possible to develop a robust grid reliant on high voltage direct current lines and so on, that's a major challenge that needs to be thought about. So to finish, just some key messages. Technically, China could reduce its 2050 emissions from about 13 to below 4 gigatons of CO2. Just to summarise where those reductions would come from, about 5 gigatons from electrification with decarbonisation of the power sector, about 2 gigatons from energy efficiency, 2 gigatons from carbon capture in the non-electricity sectors, and other fuel switching from carbon-intensive coal to less carbon-intensive gas. They would give you approximately the 9 to 9.5 gigatons of reductions that we modelled. As we know, and know even further from some of the comments earlier this evening, all of these technologies and measures are being thought about in great detail. There are key benefits to this kind of scenario in terms of reductions to overall energy demand, coal and oil in particular, and air pollution reductions, but a number of challenges which we need to think about using more detailed models of spatial planning, looking at particular areas and so on, resource usage, technology costs and grid design. So that's a lightning quick tour of the research that we've done. I hope most of you will know from the invite to this evening that the report we've written is now online and available, and very happy to answer any questions now or later on. Thanks.
Thank you, AJ. Right, AJ is willing to answer some questions, and I see one coming there. You can the mic.
Thank you. Thank you for the interesting talk. My name is Diego. I work at the research team in Longterm. And so my question relates to the relationship between economic growth and energy use. So you mentioned that in this scenario that achieves the emission reductions, economic growth is 500% from now to 2050. So it'd be interesting to know what would it be in the baseline scenario, business as usual, and if economic growth is lower in the low emission scenario, whether you have any indication or any of your colleagues from China present, whether the government would be willing to make these sacrifices in terms of growth for achieving the reductions.
Okay, thank you. The modelling that was done for this study, I don't think it provides a complete picture of all of the costs of moving from the baseline or reference case to the low carbon case, but we do have an approximate view that it would cost about 2% of China's GDP in 2050 to move from the baseline to the low carbon scenario. That's in the context, obviously, of GDP multiplying by about a factor of 6 over that period. So it is a significant, in absolute terms, cost to move to the low carbon scenario. but it's very much in line with the sorts of global estimates that we're aware of that would move the world from a business as usual path to a what you would call a 450 ppm or a 2 degree C type of scenario. I think that it's fair to say that a bit more work needs to be done to identify those costs in a bit more detail.
Okay. Right, lady there. Lady in green here.
Hi, Jay. Thank you for the talk. I'm Maria from LSE Grantham, and I just wanted to go back to basically the message you had that solar PV that would overtake wind? And I know there are a lot of cost reductions that are going into the supply for solar PV, but it seems that the power efficiency for wind technologies, especially with offshore wind turbines, would be so much greater in producing energy, and China has put so much more of their targets in deployment for wind. Could you explain more about why solar would overtake or how those reductions occur?
Sure, it's a good question. It's very much an artifact of the kind of least cost optimization energy technology modelling that we do, and it's a reflection that IASA, our partners, took a view looking at a range of studies that solar PV had a bit more potential to reduce costs compared to perhaps the conventional view. So it really is a result of that. It's very interesting that we're doing a study on India's energy technologies to 2050 right now, and we're finding in our initial scenarios that solar PV is not selected so much in India. So again, we're using a different energy technology model to that. We're using something called the Times model, and it really does reward some effort to look into the detail of exactly what those costs are. I think probably the IASA costs on solar PV are towards the low end, and that's why in the report we say if you didn't have that much PV, what would the alternative options be? The scenarios that we have are probably quite a lot lower on hydro and nuclear than some comparable studies to 2050, so those could be two options which would increase if you didn't believe the solar PV figures, for example.
Thank you. The lady next to you has purloined the microphone so you can use it.
Thank you for the very good the scenario and the model analysis. But I have two questions. First, regarding the global climate change. How do you think the global climate change it create and build the incentive to promote technology development to reduce carbon emission? But if we look at the recently debate over the carbon taxing in aviation sector between European Union and other countries, how do you think the carbon taxing of global climate change also reshape the geopolitical situation in global context? That is the first question about the global climate change. The second question...
Just one.
Okay. Thanks.
All right, I'll deal with that one. Just to repeat what I understood, if I understood your question correctly, the first part of your question was asking, I think, whether global climate change imperatives are driving forward technology developments in China. And so in response to that, just that part of the question, it's very interesting that when we began this analysis, it seemed as though a lot of the technology developments that are happening in China at the moment are very much around energy security, local pollution, gaining a first mover advantage in a growing global market for low carbon technologies and so on, and that they would actually be very beneficial actions even without the climate change imperative. So what's encouraging to see is specific policies like carbon taxation coming into China now, which are, and also, as Dr. Yang mentioned, research into things like CCS, which of course have a coal penalty, a water penalty, an energy penalty, and are justified mostly in the context of global climate change. So it's very interesting and encouraging to see those actions being developed in China now, which I think you could argue are principally because of climate change and not because of energy security, local pollution, and so on. You asked a question about carbon taxation as well. I'm not sure I fully understood that.
Well, perhaps you can answer that one afterwards then.
Sure.
Is there one more question I'll take? Okay, lady over there. And this will be the last.
Thanks. Sorry, I should have sat right at the end. It's Ria Miller. This might be relevant to some of your work in India as well. But I've just returned from Nepal, where they're doing quite a lot of work on micro renewables and it's kind of decentralised energy. And obviously that can have quite an impact on some of the smaller villages and things. It's not big scale. But I was wondering, is there much consideration of micro and decentralised energy going into these reports, or is it mostly focusing on the really big supply?
That's a good question. Within our study for China, there wasn't so much focus on off-grid generation. The electrification rate in China is greater than 99.5%, and by contrast, the work we're doing on India, where there are hundreds of millions of people without access to electricity, we're looking much more closely at off-grid solar PV, for example, as a potential technology which could help meet the rural electrification goals of India as well as the low carbon imperatives. So in this report, not so much, but certainly in the India study and those studies where there would be a need to electrify further, we would be considering that sort of thing.
Thank you, AJ. Well, we have to close proceedings now, but we all realise that China is in a key position in terms of energy policy in the world and the way climate change will go in the world. And it's been some fascinating insights tonight. And we thank the experts from the Energy Research Institute in China, Professor Han, the Director General, and Dr. Yang, and AJ Gambier from the Grantham Institute here. Thank you all for your contributions to an extremely interesting evening. Thank you.